Maths is the language of our universe. People have been practicing maths for thousands of years. Many ancient civilizations used maths in different ways, from accounting to construction to eventually maths just for its own sake.
First, we have to talk about the state of maths at the time, as it was very different to what it is now. There was no decimal base for numbers, negative numbers weren't accepted, and a decimal point wasn't used. However, despite these absences, there were still some impressive discoveries at the time, especially that from the Babylonians. Babylonian maths was written using a base 60 number system, likely due to its large number of factors. They also used a table of square numbers with these formulas to aid with multiplication. For dividing, they would multiply by the reciprocal, and they even discovered a quadratic formula for the equation ax squared plus bx equals c, where c was positive. Using these formulas, as well as the table of multiplication, they were able to simplify different operations. They also modelled exponential growth for the use of loans in accounting, and they also found solutions to some cubic equations. Greek mathematics was different to all the maths from other civilizations. All maths before Greek maths relied on inductive reasoning, in other words, repeated observations to establish general principles. But the Greeks were different. They used deductive reasoning, which relies on logic and axioms and deductions. The Greeks focused on more theoretical and geometrical maths. Something interesting from the time was the method that mathematician Archimedes used to estimate a value for pi. Let's start with the definition of pi, the ratio between the circumference and the diameter. Let's construct a circle with radius 1, and construct two squares, a bigger one and a smaller one. The side of this bigger square is 2 times the radius, or just 2, and the perimeter is 4 times that, so 8. So the circumference divided by the diameter is 4, and since the square is larger than the circle, pi is less than 4. What about the smaller square? What's the circumference of that? Well, we can find the perimeter using the Pythagoras theorem. Since the squares have equal sides, we can say 2 times a squared equals c squared, and going through the algebra, 2a squared equals 4, a squared is 2, so a is equal to the square root of 2. So the ratio between the circumference and the diameter is 2 times the square root of 2. And since the square is smaller than the circle, we know pi is larger than the square root of 2 times 2. So pi is between the values of 4 and 2 times the square root of 2. Let's move on to Roman maths. Ancient Romans, such as Cicero, an influential Roman who studied mathematics in Greece, believed that Roman surveyors and calculators were far more interested in applied maths rather than theoretical maths and geometry that were prized by the Greeks. Romans used math for managing taxes, finding surface areas, engineering, and the Roman calendar. The Romans loved taxes. Taxes from land to religion to sales. These ranged anywhere from 0.5% to 5%. They were able to use these calculations to instigate and detect financial fraud too. Here are a list of some of the taxes that they had. The ancient Romans were renowned for their advanced engineering feats. Despite their notoriety, however, they didn't contribute all that much to the field of mathematics, focusing on its more practical side. They heavily relied on arch structures to distribute the force, and were the first civilization to use them as widespreadly as they did. Using these arches, they were able to construct aqueducts between 10 and 100 kilometers long, carrying over 1,500 liters per second. Each day, 1.2 million litres of water was brought into Rome each day through 11 different aqueducts. These descended from an elevation of 300 metres above sea level and were often maintained by slaves. How did the Romans measure things? The Roman foot and the Roman mile. The Roman foot was the standard unit of measurement, which was between 29.5 and 30 centimetres long. The Roman mile was 1.48 kilometres long, just shorter than today's mile. The other units ranged from 0.2 centimetres to 2.22 kilometres. Using these units, the aqueducts would have been 7 to 68 miles long.